Okay, let's take a look at the different types of numbers there are. The first set of numbers I want to look at is the natural numbers, and sometimes these are called the counting numbers. Basically, in roster form, this is the set of numbers 1, 2, 3, etc. Now when I say roster form, I'm writing this out like a roster, like a roll sheet a teacher might use, lists the names. In roster notation, we list the elements of a set. The set of whole numbers basically is just a little bit larger, also including 0 in the set. I like to think that the 0 has a whole, H-O-L-E, in the center of it, and therefore that's my reminder that we do include 0 with the whole numbers. Now the integers include both the positive and the negative numbers. So I start at negative infinity and then go up to negative 1, 0, 1, 2, etc. And this word, integers, is a word we use quite frequently in our algebra class, and it's a word that you really should be familiar with. Notice how these answers are nice and clean, or these values are nice and clean, and there's no fractions or decimals in them. When you see that your answer is going to be an integer, that's kind of good news for you. You don't have to deal with fractions or decimals. Okay, the first thing we want to deal with is whether these different numbers are integers or not. 20 is an integer. 18 over 9 is written as a fraction but can be reduced to an integer, so yes, it is an integer. If it cannot be reduced into a nice clean whole number, positive or negative, then it is not an integer, whereas 67 is and negative 55.68 is not. The 0.68 disqualifies it from being an integer. Now, a rational number is any number that can be expressed as the fraction of two numbers, provided that the denominator is not 0. Now, we also want to include in this, so I'm going to write also include repeating decimals, because repeating decimals can also be thought of as fractions. You should all know that 0 point repeating threes is equal to 1/3, as is 0 point repeating 6 equals 2/3. That should serve as a reminder to you that repeating decimals can be written as fractions. Now, what are irrational numbers? Those are numbers that are not rational, quite simply. And an example of that might be pi. Pi, its decimal approximation goes on forever and ever, ever, and you cannot find any sequence of digits over which to put a bar. Now let's go back up here and talk about this not dividing by 0. Anytime you have a fraction, you're not allowed to divide by a 0. If the denominator is 0, then we use the word undefined. Now let's classify the following values as either rational or irrational. The square root of 64 is equal to 8, and this is actually equal to negative 8, which is an integer. However, negative 8 can also be thought of as negative 8 over 1, and since you can see that it's written as a fraction, it is rational. Negative 2/5 is actually a rational number. It is a fraction. The square root of 7, or for that matter, the square root of any prime number, cannot be written in fraction form, so it is irrational. The repeating bar over the 4/6 in this next number means that it will be rational. It can be written as a fraction. And that value of pi in negative 9 pi tells us that negative 9 pi is irrational. Now, what is a real number? A real number, quite simply, is all of the above. It won't be until the end of your intermediate algebra class when you learn of numbers that are not real. And in that case, they will be considered to be imaginary numbers.